Students, welcome to the Yupp Master Foundation program. Today we are going to deal the very important topic related to the refraction through the curved surface and principal focus and focal length. Let's see. Yeah, we are going to deal the refraction through the curved surfaces. That is very interesting topic. If we have seen reflection, it is limited to one media. That is going to be the incident light ray will reflected comes back to same. The bouncing back of the light ray is the reflection phenomena. It's okay. But while you are going to take that refraction through curved surfaces, the refraction phenomena is the light rays are entered from one medium to another medium. Suppose if we have taken rarer to denser medium, the bending of light rays, yeah, you have to take that. Yeah, you can take that refraction. Just you have to say that previously we are going to take this one. We have to see that. That is in case of plane surface. But if you have seen that curved surfaces, just you have to get the light rays, they are going to be incidented so you can take that just we have to see this is for plane surface, this is for curved surface, single refracting curved surface. This is also single refractive curved surface. Just you have to see that. So this is the incident light ray. Incident light ray. It has been refracted. It has been refracted. Suppose if you are going to take that one light ray which has been incidented in this perpendicular direction. So it does not shows any refraction. It is very clear. Here also you have to take this one. Just we have to take this, right. Yeah, we are going to take that whenever a light rays enters from one medium to another medium, that is rarer to denser medium, the light rays, the refracted light ray bends towards the normal, You have taken that this is the mu1, this is mu2, this is mu1 and mu2. All right, we have learned that whenever the light rays are entered from denser to rarer, it is different. That is, if you are taking that the light rays enters from denser to rarer medium, the refracted ray moves away from the normal. So for the first case we have taken this is the rarer medium. Just we have to take that mu1 rarer medium. Refractive index of rarer medium. Mu2 is the refractive index of denser medium. It's very clear. That's what we are going to know about all these things, which is moving towards the normal, which is moving away from the normal. In the curved surfaces, we are going to discuss that one. It is very clear. Now you can go for that. If you have taken this curved surface, yeah, just you have to see that. So the incidented light rays are going to be taken in this direction and it is going to be refracted. So this is the refracted light ray. refracted light ray. Very clear. Now, if you are going to take that, mu1 and mu2 are the refractive indices of rarer and denser medium. So, here we would like to take this one. Yeah. So, this is the ray which is incidented normally, that is, it will goes, yeah, it is moving in the straight line, just it is not at all going to be having that refraction. So, without any deviation it will moves away, right. That is what, if you are going to take that incidented light ray at in the normal incidence, it does not get the refraction, very clear. If you are going to take that, this is the focus, we are going to discuss about these things. Yeah, the incidented light rays are about to meet at one point, they are about to meet at one point. So, they have been represented with the dotted lines to initiate that focus, that is F1, alright, it is very clear. While you are talking about this refracting surface, curved refracting surface, this is the single curved refractive surface. If you are going to take that, yeah, F1 is the first principal focal length, alright, it is very clear, we will discuss that. So, they are about to meet, all the rays are about to meet at F1, then only it is known as first principal focus. Yeah, you are going to take that, the distance between the pole and first principal focus is known as first principal focal length. Let us see. Yeah, if you are going to take that, this is a one. We are going to see that if the light ray has been incidented normally, it does not get any deviation, it will follows the straight line path, very clear, alright. What happened, let us see, they are going to incidented in a one direction and they are going to be refracted. Yeah, if you are going to take that, the light rays are originated from this point, they are appear to be originated from one point. In case of convex refracting surface, single convex refracting surface, it is very clear. Let us see, this is the first principal focus. This is the first principal focus. Just while you are talking about this one, you have to take that. Yeah, if you are going to take this one, F1 is the first principal focal length, alright. Now, if you are going to take this one, the distance between the pole and the first principal focus is known as first principal focal length, it is very clear. Suppose if you are going to take that, yeah, this is case we are going to represent, the refracted light rays are parallel, the refracted light rays, simply you are going to, they are about to originate from one point and after refraction they will becomes as a parallel lines. All the refracted light rays travel in the same direction and they are going to be parallel, very clear. So, they will meet at one point, they are going to be parallel and you have to take that pole is a one point which is used to take the measurements. Simply pole is a one reference point to take the measurements. So, this is the U and this is the V. Let us assume U and V, This is the case we are going to discuss. So, can you take that this is all the light rays are going to be, all the refracted light rays are going to be parallel. We don't know where these light rays, these parallel lines or meets at infinity. That's what we are going to take that distance, it is going to be infinity. It's very clear. It is very important to identify this one. Why we are going to take that infinity. We may assume that at infinity point they are going to meet that. Actually it was not happened. So that's what we are going to take that at infinity. So here this is the u according to sign convention. Okay, all right. If you are going to take that, yeah, you are going to take that positive and negative. Just you know very well about all these things. We will discuss, right? It is very clear. Now, if you are going to take that, this is the refraction phenomena. Now, if you are identifying that in case of convex mirror, the reflected light rays are going to be diverge and they are going to be meted somewhere else. Yeah, that is very clear. We will discuss. Here, what is our aim? We are all going to calculate that F1 is equal to question mark just. So, the sign of F1 depend on radius of curvature, sign of radius of curvature. Very clear. We are going to take this one. If you know the radius of curvature is going to be positive and it's going to be negative sometimes, just we are going to obtain the relation. Yeah, do you know very well about this one? If you are going to take that mu2 by v minus mu1 by u is equal to mu2 minus mu1 by r. This is the relation we would like to get the expression for this focal length. First principle focal length. Let's see that. All right, let's go for another one. It's very clear. It is going to be, yeah. What about that r? R is the radius of curvature. Now here, what do you mean? Convex refracting surface. Yeah. If you are going to take that one curved refractive surface which separates that rarer and denser medium, and it is going to be bulged at the center, it's going to be bulged shape. At the same time, if you are going to take that concave refracting surface, that is going to be depressed. Yeah, you have to take this one. It's very clear. We would like to take this one. Right. Now, if you are taking that, right, here we are all having that awareness about this general terms. What about that xy? Just you have to take this one. Xy is the aperture. All right. Now you are going to take that P is the pole. All right. And R is the radius of curvature. All right. R is the radius of curvature. C is the center of curvature. Okay. Now, if you are going to take that mu1 and mu2, this is about refractive index of rarer medium, refractive index of rarer medium. Right. Mu2 is the refractive index of denser medium. It's very clear. Now, if you are identifying the phenomenon, that is, in case of concave refracting surface, there is a depressed part which is going to be inward, and the position of that principal focus and the first principal focal length are represented. Right, here you would like to know about these parameters. Now, if you want to estimate the relation among the parameters mu2, mu1 and R and F1, just you have to follow the one expression. Let's see. It was happened in case of concave refracting surface also. Previously we have seen that convex refracting surface. All right. Now it is the same case, we have seen that, right? Yeah. We are going to take that C is the center of curvature. So the center of the distance between the pole and the center of curvature, it's going to be R, radius of curvature. So it is the imaginary part what we are going to complete the sphere. In order to have the geometrical relations, we have to consider C is the center of the sphere, R is the radius. So we would like to continue the geometric relations, and we would like to calculate the object distance and image distance in case of curved refracting surfaces. All right. If you are taking this one, this is a single refracting surface, that is concave. Yeah, you have to take this one. Yeah, this is the concave refracting surface. All right. Now, if you are taking that, yeah, from this pole, it's going to be, R is going to be, just you have to take this. Yes. Yeah, you have, according to that sign convention. So this is the R, let's assume. Yeah. Okay. So we are going to take this one, P is a 1 point pole, right? And this is the positive, this is negative. So we are all identifying that R is going to be negative. Yeah, we can take that. The sign of R can influence the sign of focal length. It is very clear. Now let's go for another one. Here, principal foci. If you are talking about that principal foci, you have to identify that the light rays are going to meet at one point. They are all going to meet at one point, that is converging. The light rays are going to diverge they are about to meet in one point. Just we have to identify this one. Each refracting surface has two focal points. These are all called principal focal points, and their distances are going to be measured from the pole. The distance between the pole and the principal foci are known as focal lengths. Just we are going to take that. This is the focal length. Right. Let's go for first principal focus. It is going to be identified with F1. Yeah. And second principal focus F2. You have to locate this first principal focus and second principal focus in curved refracting surface. Let's see. Yeah, if it is going to be identified that, so F1 is the first principal focus in case of convex refracting surface. Do you know these, the light rays are going to be originated from the point. The light rays are originated from a point and they are all going to be parallel after the refraction. Yes. So, they are going to be originated. Sometimes they are going to be meet at one point. That is, they are going to be converged in case of concave refracting surface. Just we have to see, this is the case, we are going to take that. Now, if you are taking that, this is the case we would like to discuss, right. Okay. Now, if you are identifying that F1, capital F1, that is the first principal focus, that is F1, right. Now, small f2, F1 is the first principal focal length. Just we have to take this one. You need to get the expression, right. Suppose you are going to taking that expression for this first principal focal length. Let's see. Yeah, this is the second principal focus. You are going to take that. Yes. So, this is the case we are going to identifying that they are all about to meet at this point. You have to take that, this is the second principal focus. We will get this second principal focal length is also going to be F2. It's very clear. Now, if you are taking that sign, it's going to be positive. Yeah, if you are going to take that F1 and F2, in case of convex refracting surface, F1 is negative. In case of concave refracting surface, F1 is going to be positive. If you are going to take that F2, it is also going to be taken, it is positive for this concave refracting surface. Just we have to see, and we will derive the expressions also, whatever it may be. Just we have to see that. Yeah. Just we have to get the expression. While you are going to take that, please see that. Yeah, you know the relation. when the angle of incidence and the angle of refraction are going to be very small. You have to get this relation. That is very clear. Yeah, you can take that mu2 by v minus mu1 by u is equal to mu2 minus mu1 by r. All right. This is the relation in case of the refraction through a curved surfaces whenever the light rays are entered from rarer medium to denser medium. Now you are going to take that, yeah, let us see, in this case, yeah, if you are identifying that from the pole, we are going to take this one, pole P, yeah, from the pole P, right. So you are going to take that u and v, just object, yes, object distance and image distance. So while you are talking about that formation of image, the refracted light rays can form the image at a particular point depending on their position, where they will meet, that is also important. In this case, in order to get this image distance, these light rays are going to be parallel, very clear, and they are going to meet at somewhere else. All right, they are going to meet at somewhere else, that is infinity. At infinity they will meet. Here you are going to get this u and v. Yeah, this is the object distance u, that is for, you can take. All right, simply the refracted rays are going to meet at somewhere else, and we are going to consider that is at infinity point, right. So you can take that, it is going to be infinity, right. You can take that, that is f. So u is equal to f. All right, it is very clear. We are going to know about this one, right. Then you can get this one. This is u2 by, what about infinity, minus u1 by, what is u? f1. Please take that f1. Yeah, this is u. What we are going to take that, right. Now you can substitute here. It is very important. That is, you can take f1, right. It should be going to have the expression u1 by r. All right. Now it's going to be 0, just 1 by 0, just you have to get that expression, minus, this is going to be 0, just you have to get this one by f1, that is mu2 minus mu1 by r, right. So from this above expression you can write f1 is equal to minus mu1 r by mu2 minus mu1. This is the expression for first principal focal length, right. So f1 is the first principal focal length. First principal focal length. Yes. Can you say F1 is negative for the convex refracting surface, that is convex single convex refracting surface, we are going to take that one. So, here it is very clear, you are going to take that, right. So, this is for F1, just we are going to take that F1 is negative, the sign if you are going to take that F1 is negative, just you have to take this one. Just in this way we will get the expression for F1 in case of single concave refracting surface also, right. While you are talking about that sign, yeah, the sign of F1 depend on sign of R also, right, it is very clear. So, you are going to get that the position of object and the position of image can be estimated on the nature of the refracted light rays, it is very clear. Now, if you are going to take that, in previously what you have learned in case of reflection, if the light rays are going to incident on the curved refracting surface, curved surface, from somewhere else they are going to coming. So, at infinity distance they are going to form that point size image, that is the highly diminished image. Here also we are going to take that the characteristics of the image in case of refraction. The refracted light rays can form the image, it is very clear. So, where they are going to meet on the principal axis? Very simple, the light rays, the incident light rays cuts the principal axis, this is going to be principal axis, we are going to know about this, this is the principal axis. Just we have to see. Yeah, this is the principal axis. So, these are going to be parallel to the principal axis, no doubt at all. But in case of concave refracting surface, let us see what happened, and we would like to calculate that F1 also and the sign, and we will estimate, right. Let us see. Yeah, while you are taking that, this, you know, this is concave refracting surface. Yes, which is going to be identified that the incident light rays are about to meet at this point, but actually it was happened, the incident light rays refract, they are going to be refract, and if you are going to consider, that is mu1 is the rarer medium, mu2 is the denser medium, the refracted light rays, they will move towards the normal. That is the case, we will discuss. At the same time, if you are knowing that they are about to meet, if they are going to be extended at this point F1, we would like to get this one, that is F1 be the principal focus. Previously you have seen that this is the F1. Yeah, just you have to take this one. So, they are going to be, yes, F1, this is for convex. Yeah, you are going to take that it is in front of that surface. This is behind the surface, curved refracting surface. Very clear. Now, we are going to take this. Yeah, you are taking that mu 2 by V minus mu 1 by U is equal to mu 2 minus mu 1 by R. Now, it is very clear, you are going to take that. Here, you will identify that V is equal to F1. Here, V is equal to F1, U, you have to consider. Just you can get the expression if you are going to take this one. Right. Therefore, mu 2 by F1 minus mu 1 by infinity is equal to mu 2 by mu 2 minus mu 1 by R. It is very clear. If you are taking that, F1 is equal to mu 2 R by mu 2 minus mu 1. It is very clear. So, F1 is positive. It is very clear. F1 is positive for concave refractive surface. So, F1 is negative for convex refracting surface. Right. This is about all the sign what we have obtained for concave refracting surface and convex refracting surface, that is first principal focal length. Right. Let us go for another one, second principal focus. Yes, you have to see that second principal focus. Yeah, it is the F2 is the second principal focus. If you are going to take that, yeah, second principal focal length. This is the second principal focal length. You can easily find out that F2 by using the relation. Okay. Right. Let us go for the expression for second principal focus. It is going to be negative, just we have to imagine. Right. Now, if you are going to take the same relation, mu 2 by V minus mu 2 by U. Right, is equal to mu 2 minus mu 1 by R. Here we would like to get this one. Here mu 2 by V, it is going to be F2 is minus mu 1 by infinity, that is mu 2 minus mu 1 by R. All right, you will get that F2 is equal to mu2 or by mu2 minus mu1. This is very clear. F2 is positive for convex. F1 is negative for concave. But if you are going to take that F1, that is going to be negative. Alright. In this way we can learn the basic fundamentals and we will apply to the problems, whatever they have reflected in entrance exams and your annual exams. Okay, thank you very much. Have a nice day.